Namaste to all. Welcome to the online classes of Vivekananda Pre-University College, Puttur. I am Shruthi. So, we are discussing the topic relations and functions. In the last class, we had discussed the exercise problems of 2.3. Okay. Now, in this class, let us move on to the miscellaneous examples. Okay. We have some 4-5 problems in the miscellaneous example. We shall solve those problems. Okay. Miscellaneous examples. Example number 18. Okay, 18. What is the question? The question is, let R be the set of real numbers. Okay, I will denote the set of real numbers by these two lines. Okay, set of natural numbers with the n with one more extra line. Set of all rational numbers with the q and one more extra line. Okay, R be the set of real numbers. Then define the real function. Define a real function. The real function. How? Define the real function f from R to R. R is set of real numbers here. By f of x is equal to x plus 10. X plus 10. Okay. What we need to calculate? Sketch the graph of this function. We need to sketch the graph. How to draw the graph? You already know. Sketch the graph of the function. That is the work we need to do here. First, what we need to do for that? For drawing the graph, what we need to have? We need to have the functions, value of the function, right? So, the first one is f of x is equal to x plus 10 we have. We will start from x is equal to 0. For x is equal to 0, what we have? F of 0 is equal to 0 plus 10, that is 10. Okay. Then for f of x, x is equal to minus 1, what happens? Minus 1 plus 10, that is x plus 10, right? X is minus 1. Minus 1 plus 10, that is 9. F of 1 is 1 plus 10, that is 11. F of minus 2 is minus 2 plus 10, that is 8. F of 2 is 2 plus 10, that is 12. F of minus 3 is minus 3 plus 10, that is 7. Okay. And f of 3 is 3 plus 10, that is 13, right? That is 13. F of 3 is 13. Okay. These are the values. Okay. Now we shall draw the graph. For that we will have the coordinate axis. This is x axis, this is y axis, this is y dash, this is x dash, 0, 2, 4, 6, 8, and we will have the, okay, 2, 4, 6, 8 and 10, and minus 2, minus 4, minus 6, minus 8, minus 10, and 2, 4, 6, 8, 10, minus 2, minus 4, minus 6 and minus 8, minus 10. Okay. Now, look at this. At x equal to 0, we have the function value to be 10. Okay. So, x 0 ಆದಾಗ y 10 ಆಗುತ್ತೆ. ಈಗ y 0 ಆದಾಗ x ಏನಾಗುತ್ತೆ? Just see that. If we have f of x is equal to 0, then what is our x? See, f of x is equal to 0, what is our x? What does that imply? X is equal to minus 10. So at x is equal to minus 10, what we get is y is equal to 0. So x is equal to minus 10, comma 0 is a point, okay. Then x is equal to 0 and y is equal to 10 is a point, okay. So by joining these two lines, we will get the graph of f of x is equal to x plus 10. This is how we draw the graph of function. Note that this function is of the form y is equal to mx plus c. Such a function is known as linear function, okay. So this is a linear function. I hope this is clear, okay. This is about the first problem. I hope you are clear with this, okay. Now let's move on to the next example. Next example is next problem is example 19. Okay. Let R be a relation from Q to Q defined by, let R be a relation, okay, it is a relation given, relation from Q to Q. Q is set of all rational numbers, Q to Q, given by, defined by R is equal to, this is not real numbers R, it is a relation, okay. Set of all ordered pair AB such that A comma B belongs to Q and A minus B is A minus B belongs to Z. What does that implies? That implies A minus B is an integer, okay. This is the question, this is the relation, okay. What we need to do? Show that the first question is set of all, okay, A comma A belongs to R for each A belongs to Q. This we need to show. The second one is A comma B belongs to R implies A comma B belongs to R implies that B comma A also belongs to the relation R. B comma A belongs to the relation R, okay. The third one is A comma B belongs to R and B comma C belongs to R implies that, what does that imply? That should imply that A comma C belongs to R. A comma B belongs to R and B comma C belongs to R should imply that A comma C belongs to R. These things we need to show. So relation hege define agide? See, relation is defined like this, that of all ordered pairs AB where A comma B belongs to Q, A comma B are rational numbers while A minus B is an integer. This is how we define the relation. For first, see A comma A, whether A comma A belongs to R, this relation clearly A minus A is equal to 0, right? 0 is an integer, so 0 belongs to Z, right? So what does that implies? This implies that the ordered pair A comma A belongs to R. See, simple. The second one is, we are given that ordered pair A comma B belongs to R. What does that imply? A comma B both are rational numbers and A minus B should belong to Z, that is A minus B is an integer. See, if A minus B is an integer, then minus of A minus B is also an integer, right? What is minus of A minus B? See, A minus B anta heludu integer adre, then we have minus of A minus B is also an integer. If 2 is an integer, then minus 2 is also an integer. If 100 is an integer, minus 100 is also an integer. If minus 100 is an integer, then minus of minus 100, that is plus 100 is also an integer. So minus of a minus b is also an integer. What is that? That is b minus a. Okay. So this implies b minus a is also an integer. What does that mean? That means that the ordered pair b comma a belongs to R. Okay. Now coming to the third one. Third one is a comma b belongs to R and b comma c belongs to R. What does that mean? That means that a minus b is an integer and b minus c is also an integer. A minus b belongs to z and b minus c belongs to z. Okay. By adding these two, what we will get? A minus b, add a minus b and b minus c. What we will get? We will get a minus c. See, a minus c is equal to a minus b plus b minus c. B cancels. So, we get a minus c by adding a minus b and b minus c. See, these two are integers. Adding any two integers will yield again an integer. So, a minus c is also an integer. What does that mean? That means that the ordered pair a comma c belongs to the relation R. Clear? Okay. Now, next problem. Next problem is okay. This we have showed these things. Now, coming to the next problem. Next problem is this is example number 20th. 20. Question is, let f is equal to, we are given a set, okay, f is equal to the ordered pair 1 comma 1, the ordered pair 2 comma 3, okay, and the ordered pair 0 comma minus 1, 0 comma minus 1 and the ordered pair minus 1 comma minus 3, minus 1 comma minus 3. These are the given ordered pairs in the set S. F be a, this be a linear function. This is a linear function. Okay? This is a linear function from Z into Z. From Z into Z. Z is set of all integers. Okay? Z into Z. Find f of x. F of x. Find f of x. See, what is a linear function? A function of the form f of x is equal to mx plus c is known as linear function. A function f of x is equal to mx plus c is known as linear function. So, we need to find what is f of x here. We are given the values, function values here. So, using this, see, we have 1 comma 1, ordered pair 1 comma 1 belongs to f. Okay? What does that mean? That implies f of 1 is equal to 1. Since it is given that f is a linear function, let f of x be equal to mx plus c. Okay? For some real numbers m and c. M and c are real numbers here. M and c are real numbers. Okay? See. Now, f of 1 is equal to 1. So, m into 1 plus c is equal to 1. What does that imply? That implies f of x is equal to, f of 1 is equal to 1. That is, m into 1 plus c is equal to 1. That is, m plus c is equal to 1 we have. Okay? Already we have one more thing. 0 comma minus 1. 0 comma minus 1 belongs to f. What does that imply? That implies that f of 0 is equal to minus 1. What is f of 0? M into x plus c. X is equal to 0. That is, m into 0 plus c is equal to minus 1. That implies c is equal to minus 1. We have c is equal to minus 1. Substitute this here. What we will get? M plus c is equal to 1 implies m minus 1 is equal to 1. That implies m is equal to 2. Alva? Okay, I hope this is clear now. So what we need to do? We already assumed that f is a function, f of x is equal to mx plus c, and by the calculation what we get? We got c is equal to -1 and m is equal to 2. What does that imply? That implies that f of x is equal to mx plus c, where m is 2x plus c is -1. So 2x minus 1. This is the function. This is the given linear function. I hope this is clear for you. Okay? Okay, let's move on to the next example. That is clear, no? See, linear function is a function of the type f of x is equal to mx plus c, where m and c are real numbers. So, we are given some value of the functions. What we need to do? We need to calculate what is what is c, and then we will write what is mx plus c. Coming to the next example. Example number 21. Find the domain of the function. Find the domain of the function. Function is f of x is equal to it's a rational function. See, numerator we have x square plus 3x plus 5. Okay, and in the denominator we have x square minus 5x plus 4. We need to calculate the domain of this function. See, we need to calculate the domain of the function f of x is equal to this. What does that imply? This denominator should not be equal to 0. Okay, how can we factorize the denominator? We have x square minus 5x plus 4 is equal, this is equal to, how can we factorize this? See, this is p plus q is equal to minus 5. You have studied this factorization in the high school level. pq is equal to 4. Then what is p? What is q? 4 into 1 is 4. Okay? And minus 5 we need to get. Adding 4 and 1 we get 5. Adding minus 4 and minus 1 we get minus 5. So, we can factorize like this: x square minus 4x minus x plus 4, that is x into x minus 4 minus minus 1 into x minus 4, that is x minus 4 into x minus 1. This is how we can factorize. So, this is a factorization of the denominator, x square minus 5x plus 4. So, denominator should not be equal to 0. That is how domain should be. So, this must not be equal to 0. What does that imply? X should not be equal to 4 and x should not be equal to 1. So, domain of the function is equal to r minus those two integers 1 and 4. 1 and 4. This is about the domain of the function. I hope this is clear. Okay. Now coming to the last example, that is, write the question, example 22. Okay. The function defined by f of x is equal to three ways. They have given the function 1 minus x for x less than 0, 1 for x is equal to 0, and the last one is x plus 1 for x greater than 0. Okay. This is how they have given. Draw the graph of f of x. Draw the graph of f of x. See, f of x is given to be 1 minus x for x less than 0, and f of x is equal to 1 for x is equal to 0, and f of x is equal to x plus 1 for x greater than 0. Draw the coordinate axis. This is x, this is minus x dash, y, y dash, 0. Okay. See, for x is equal to 0, what we have? Y is equal to 1. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4. Okay. If x is equal to 0, minus 2, minus 3 and minus 4. For x is equal to 0, we have y to be equal to 1. Okay. 0, 1 is a point. See, if x is less than 0, then take x is equal to minus 1. Then 1 minus x. X is equal to minus 1. Then value is 1 minus minus 1. 1 minus x is 1 minus minus 1. That is 1 plus 1. That is 2. The value is 2. For minus 1, the value is 2. 2. Okay. Minus 1 comma 2 is a point. Then if x is equal to minus 2, what is the value? X is equal to minus 2, then 1 minus minus 2, that is equal to 3. 3 is the value of y for x is equal to minus 2. This is the point. Okay. Now in the positive side, what happens? If x is equal to 1, then x is clearly greater than 0, then value of f of x is x plus 1. That is 1 plus 1, that is 2. 1 plus 1, that is again 2. So for 1 also, the value is 2. Okay. Now if x is equal to 2, then 2 plus 1, that is 3. 3 is the value of y. Okay, like this we get. So by joining the lines, what we get? For x is equal to 3, what I get? For x is equal to 3, 3 plus 1, 4 is the value. So here I will get the next point. The next point will be here, and from x is equal to minus 3, 1 minus minus 3, that is 4. So here I will get the next point. Okay. By joining the points, I will get the graph of the given f of x. This is the given graph. This is f of x is equal to 1 plus ax or x plus 1. Okay. This is the function f of x is equal to 1 minus x. And here we have x is equal to 1, if x is equal to 0, we have f of x is equal to 1. This is how we plot the graph of the given function. I hope this is clear for you. In the next class, we shall discuss the miscellaneous exercise. That's it for today. Thank you.